This is preview video 8.7, spheres. Sit tall. Ready? Inhale. Deep breath, hold. And exhale, 5. The moment ready, inhale. Hold for 3. Exhale, 5. Close your eyes, inhale. Hold for 3. And exhale, 5. Alrighty, friends, let's get started. We're going to be talking about spheres today. And oh man, I love spheres. Spheres are so much fun for a variety of reasons, not the least of which is we live on one. Don't forget date, time, and location. Let me tell you why I personally love spheres. What makes spheres so amazing is we're going to be talking about the word sphere and surface area and volume. Why I like spheres. One, they're easy to draw. We're talking about geometry spheres, not the artistic where you have to shade and all that. But so for geometry sphere, all you have to do to represent a sphere is you draw a circle. And then you sweep around kind of an equator here and you dot the back. Sweep around and you dot the back. The dotted back represents depth. And that would be a radius, and you're done. That's it. Circle, equator, dot the back, you're done. There's no lateral area. Lateral area is like the area of a label on a can, and then there's surface area. And there's only one thing, one tiny little thing. You don't have to know the difference between slant height or altitude and true height. You don't have to worry about a diameter. You don't have to worry about area of a base or any of that. All you need is one tiny little thing, and that is the radius. That's all you need. Just a radius. So, couple things you want to remember. We're going to learn about the surface area of a sphere. We haven't really focused on surface area on other shapes, but because it's so easy with the sphere, a surface area would be like the felt made for this tennis ball. An area is a two-dimensional concept. So it's like wrapping paper. I have a little diagram of what surface area would look like here. Okay, so what that's saying is if you watch it, if we unwrap the outside of a sphere, okay, you should have noticed that the longest segment is the circumference of the sphere, which is PSATs, they will use for circumference, they will use 2 pi r. So that edge length would be the circumference. Just kind of watch as we go on here. And it unwraps. That's 2 pi r. And then it's going to take every piece on the outside and unwrap it here. Rearrange all those pieces of area. So that one edge length is 2 pi r. And then the other length is 2 of the radius. So 2 pi r times 2 of the radius is the surface area. So that would be the felt around here for surface area. So surface area sphere is 4 pi r squared. That's for surface area. Volume is a 3-dimensional concept. Think the gift inside. Volume of a sphere, 4 pi r cubed over 3. Let me just point something out to you. Area is 2 dimensions. So we use r squared. Volume is 3 dimensions. We use r cubed. Surface area of the sphere, 4 pi r squared. Volume of a sphere, 4 pi r cubed over 3. I'm going to explain the r cubed over 3. That requires a half page of proofs. For the moment, we'll just roll with that. These must be memorized. Let's do a problem together. Finger right there, out loud. Be disciplined. Actually do this with me, okay? Finger right there, out loud, ready, read. The volume hopefully you actually read it out loud. I was reading it so you could silently, so you can hear your own voice. Remember, you always start with what you have, not with what you need. So even so, we have the we want the surface area. It says find the surface area. We are starting, we have the volume. So we're going to start by writing volume is 288 pi meters cubed. We want the surface area. So we're just going to write the equation out. 4 pi r squared. So you start with what you have, not with what you need. So we have the volume. So we're going to start with the volume. Volume equation is 4 pi r cubed over 3. The only thing we need to solve for all of this is the radius. So they're both volumes, so that's equivalent right here. Pop this over 1. We're going to cross multiply. Coming over here, I have 4 pi r cubed equals 3 times 288 pi. Key to multiplying is not multiplying. It's factoring. So I'm going to So when you cross multiply here, the key to multiplying is not to multiply, but to factor. That's why the 3 and the 288 were not multiplied here. We're going to divide out the 4 and the pi because we're trying to get that radius by itself. Obviously, the pi's cancel. We know 4 doesn't go into 3, but it's going to go into 288. I'm going to do that longhand in the margin here. And 4 goes into 28 7 times. 4 goes into 872. So I have r cubed equals, and that is 3 times 72. Now, here's the tricky part, how to do cube roots. So in a square root, the rule was this. If you have a date, that means a pair, then the pair gets to go out and come out as a single unit. So a square root, technically, when you normally do a square root, technically there's a 2 there, but we don't write it down because that's the baseline. So if you have a date, you get to go out. So taking a look here, we're going to cube root both sides, and I'm going to tree both of these, and I have a 3 and a 1, and I'm going to just keep going down here. I have a 2 and a 36. I'm going to bring 2 all the way down, 2 and 18, 2 and 9. And then we have a 3 and a 3. And you take a look here at your triplets. It's triplets because it's a cube root. And I have 1, 2, 3 sets of 3s, and 1, 2, 3 sets of 2s. So in square roots, you bring out the pairs. In cube roots, you bring out the triplets. And I have a triplet of 3s. So 1 comes out. And I have a triplet of 2s. So that comes out. So just to kind of keep track of what we're doing, the cube root of the radius here is going to be 6. Ta-da! Remember, all you need for anything with spheres is just the radius. That's all you need. So now that we have our radius, what we want is surface area, 4 pi r squared, and it's 4 pi circle, plug, chug, get it done. 6 times 6. It's obviously 36 times 4. So our surface area for that sphere is going to be 144. Keep it in pi form, meters cubed. A few of you have learned something. For example, cube roots might be something new to you. I recommend you summarize it before we move on. So pause the video and summarize. Let's do another one. Again, put your finger where that dot is. I'm not going to read it out loud because you're going to read it out loud. Put your finger right there. Ready? Out loud. Read. All right. So you start with what you have, not with what you need. So we start with what we have. We have the circumference. Just to reinforce what that is, we have the circumference. We're heading towards both the surface area and the volume. So we'll just write those equations down. Come up here, and we know that we've got C, d pi, I c d pi, C, d pi, I c d pi. So we got that our diameter here is 26 inches, which makes our radius, of course, half. Now we have everything we need. Bring it down here. We have 4 pi 13 squared You should know your squares at least through 15. That's 169. So we're going to go 4 times 169. 36, carry the 3. 4 times 6, that's 24, 25, 26, 27. And that's going to be 676. So our surface area is 676 pi. Check units, inches squared. Coming over here, I have 4 pi, and it's going to be 13 times 13 times 13 over 3. Now, we can't reduce that 3 into any singular number, so we're just going to leave it here. And it's going to be a fraction, which is totally fine. So 4 times 13 times 13 times 13. You get 8788. Volume equals 8788 pi over 3 inches cubed. Then to do approximate, of course, you just do 676 times your pi key. Round it to the tens place is fine. 2123.7 inches squared. There's your surface area. Volume. We have 8788 times pi and divide by 3, 9,202.8 inches cubed. Start with what you have, not with what you need. Again, finger right there, out loud. You are reading and go. Wait a minute. I think we did that one already. Yep, we did. Lucky you, we already did that problem. In fact, you know what? I want you to do that without flipping back. Come on, don't flip back. You can do it. See if you can't recreate that problem on your own. Pause the video, do it yourself. Check yourself. Were you able to recreate on your own? Hopefully you did. On that note, folks, this page is on your own. Pause the video again, restart when you're done. Pause. Welcome back. Let's see how you did. Says here, find the surface area and volume with a diameter of 6 miles in exact and approximate form. Surface area equals 4 pi r squared. 4 pi, not 6, of course. Pick up the radius. Always physically trace that radius. Right here, our radius is 3, so 3 times 3. So that means, of course, your surface area is 36 pi. Check units. Miles squared. You should have the approximate of your own terms. I'm not going to give that for you, but I will be checking it on your preview notes to check that you did your own work. Volume, 4 pi r cubed over 3. 4 pi 3 times 3 times 3 over 3. 3's cancel. Boom. Now, you're looking at this kind of wonky, like, where it looks like the same number. Okay, because that's 9, that's 4, that's 36 pi. But careful, friends, it is not the same number. Let me explain. Okay, that looks like it's the same number, but it's not, because the units are different. Think of it like this. Let's say I had 3 at $5 bills. And then in another pocket, I had 3 at $20 bills. So in one pocket, I had 3 $5 bills, and another pocket, I had 3 $20 bills. And you're thinking, that's not the same amount of money. 3 and 3, nope, not the same amount of money, because my units are different. I have 3 and my unit is $5 bills versus 3 and my unit is $20 bills. So it's not the same amount of stuff. So don't necessarily second guess yourself. If you get something that looks like this and you're like, it's the same thing, it's not, because your units are different. Just like here, your dollar bills are different. Summarize today's lesson in your own words and the main things you want to remember.